All right, we're going to go over problems 6 through 10 on the 2015 Geometry Regents exam from last year. So as you're looking here, I want you to write down the properties that are preserved under a dilation. What that means is when you do a dilation, these are the things that are going to remain the same. So I have 5 listed here. The angle measures will always remain the same. Uh, Parallelism, which means the parallel lines will remain parallel. Collinearity, that means points stay on the same lines. The midpoints remain the same in each figure, and the orientation, which means the lettering order remains the same. So let's look at what the question says here. It says the image of triangle ABC after a dilation of scale factor K centered at point A is triangle ADE. So this means that the image is larger than the pre-image, which means that the scale factor had to be above 1. So let's look at our statements, and it asks which statement is always true. Well, if you look at our properties that are always preserved, we notice that nothing is mentioned about lines being perpendicular. If you look at the first answer choice, it says 2AB is equal to AD. Well, it might be. If the scale factor was 2, then that would be true. But if the scale factor wasn't 2, that would not be true. And we don't know what the scale factor is, so that would not always be true. Now, would AC be congruent to CE? It could be. If the scale factor was 2, actually that would be the case also. But we don't know what the scale factor is. We're looking for something that would always be true no matter what the scale factor was. And the only one that will always be true is number 4. BC will be parallel to DE. All right, and that's what those two little lines mean. They're up, almost look like an 11, but that means parallel. So our answer to number 6 is number 4. Now remember, I'm going to want you to write down these notes in order to get full credit. So make sure and do that. All right, number 7. It says a sequence of transformations maps rectangle ABCD. So that's this one right here, ABCD, onto triangle, rectangle ABCD, well, double prime. So A prime, B prime, A double prime rather, A double prime, B double prime, C double prime, and D double prime. So that is actually over here. So it's a sequence, which means it's one transformation then another. So we know something happened to get the shape here and then here. All right, so let's take a look at our choices. So we have which one maps ABC. So I'm looking down here now. Which sequence of transformations maps ABCD onto A prime, B prime, C prime, D prime, and then maps A prime, B prime, C prime, D prime onto the A double prime, B double prime, C double prime, D double prime. All right, so focus first on what would make this original, so I'll do 1, 2, 3. What would make the figure go from 1 to 2? Well, if you look here, it cannot be. You might be tempted to think, well, let's look at our answers, and we'll go from there. So first, a reflection followed by a rotation. So is it a reflection followed by a rotation? Or is it a reflection followed by a translation? Or is it a translation followed by a rotation? Or is it a translation followed by a reflection? Well, if you look here, if you notice, if you were to just translate this original down, the B would still be on top. Remember, when you move it, the orientation stays the same. So if you notice, if you translated this figure, the letters would be in different places. So B would still be on top and C would still be on the bottom, which is not the case. That tells us it is definitely not a translation. Remember, translating is moving a figure, just simply shifting it to the left or right or down or a combination of both. But the order of the lettering is not going to change. The orientation of the letters is not going to change. So let's look at 1 and 2. Focus on those. Right, so number 1, a reflection followed by a rotation. Well, I would definitely say reflection, our only 2 answer choices are reflection, so it has to be that first. But so now our issue is it going to be a reflection followed by a rotation or a translation? Well, if it was a reflection followed by a translation, so that would mean a translation from 2 to 3, so from here to here. When you do a translation, the order is not going to change. You're not going to have a shape flip. Now, it might move like this, and you might have it be, like this, and you could have D, A, C, B, but it's never going to flip in the way it did to A prime or A double prime, how it is on this one. So the only option is going to be a reflection followed by a rotation. Okay, number 8. It says in the diagram of parallelogram, F, R, E, D, shown below. ED is extended to A, and AF is drawn such that AF is congruent. Remember, that means congruent, that sign in the middle, is congruent to DF. So I'm going to go ahead and mark that. AF is congruent to DF. And they're asking if the measure of angle R is 124, that's 124 degrees, what is the measure of angle AFD? So what's the measure of angle AFD, which is that angle up there? Always be careful. Look at the angle you're trying to find. You might find all of the angles and then, not recognize what they're actually asking you to find, and then pick the wrong answer. So don't do all that work and then not answer the question. All right, so now I want you to write down the properties of a parallelogram. Make sure that's in your notes. I want to see that. All right, if you are a parallelogram, you have 2 sets of parallel sides, 2 sets of congruent sides, opposite angles congruent, consecutive angles are supplementary. Remember, this means add up to 180 degrees. Diagonals bisect each other, and diagonals form 2 congruent triangles. So one of these will probably help us, maybe more than one, but let's look here. So let's look. It says opposite angles are congruent. Well, opposite would mean this angle. We already know this angle is 124, so we know that this angle must be 124. And what else do we have? Consecutive angles are supplementary. Well, consecutive would be angle R here and angle E. So they're supplementary. That means they must add up to 180. So that must mean that this is 56, because 124 plus 56 is equal to 180. Then we look over here, and we must have an angle here that is 56 because opposite angles are congruent again. So we have 56, 56, 124, 124. Now we're looking for angle AFD. So let's not forget about what we're looking for. We're looking for this angle here. And we don't know what that is yet. Now, we have this triangle here, ADF or AFD. So triangle AFD is what type of triangle? You should know what type of triangle that is. It is an isosceles isosceles triangle. And what does an isosceles triangle have? Two sides that are equal and the opposite angles are equal. So that might help us out. Now, what do we know about this right here? Well, we know this is 124. This entire angle makes a straight line, which is a linear pair. So these two angles together, this one here and this one here, are a linear pair, which means they form a line or they add up to 180 degrees. That means that this must be 56 degrees. And if that is 56 degrees, then that means that this one is 56 degrees because we have an isosceles triangle. And since we have a triangle, we know a triangle adds up to 180 degrees. So this angle that they're asking us for is the third triangle, or third angle in the triangle. Okay, hold on, I'll be right back. Okay, sorry for the interruption. Let's get back to what we were doing here. So we have a triangle. If I take that triangle, and now I basically have 56, 56, and what is this? Well, we know that the triangle has 180 degrees in it. So if two of them are 56, that adds up to 112. The other angle has to add to that to get 180. So you can do 180 minus that, which ends up being 68 degrees. All right, for number 9, I'm going to put this in the standard form for the equation of a circle. And I'm going to have to complete the square twice with x and with y. So I'm going to move this down a little bit. I'm just going to rewrite it here. 4x plus y squared minus 6y minus 12 is equal to 0. What I'm going to do is move this 12 over. Plus 12 plus 12. I get x squared plus 4x plus y squared minus 6y is equal to 12. Now, in completing the square, I'm going to do it with the x part first. Then I'm going to do it with the y part. So what you have to do is take half of this value and then square it. And then add it over here. So we have x squared plus 4x. Half of 4 is 2. 2 squared is 4. All right? Now, you can't do this to this equation because you change it unless you add 4 to the other side also. I'm going to add 4 over there. Now, with the y term, I'm going to have plus y squared minus 6y. Now, half of negative 6 is negative 3. Negative 3 squared is plus 9. And remember, you have to add 9 on the other side to balance it out. So now we have x squared plus 4x plus 4 plus y squared minus 6y plus 9 is equal to 25. That's, how do I get 25? By adding up the 12, the 4, and the 9. All right, now, the reason why you complete the square is because now you can write this as x plus 2 squared plus y minus 3 squared is equal to 25. All right, now, for the standard form of a circle, to get the center point, you're going to take the opposite of this x value here, the opposite of this y value. So your center would actually be negative 2, positive 3. That'd be the center. They're not asking us for the center, though. They're asking us for the length of the radius. So the radius is always going to be over here, r squared. So once you get into the standard form, you have to take the square root of that to get the radius. So the radius is going to be 5. So our answer is number 3, 5. All right, let's look at number 10. It says, given line segment MN shown below. That's this one right here. with m is negative 6, 1, and n is 3, negative 5. What is an equation of the line that passes through point 6, 1 and is parallel to mn? All right, so a couple things I want you to write down. So we want a line that's parallel to this one, but it also goes through this point. So you can't just write any old equation because it has to have the same, well, it has to be parallel. And if it's parallel, it means it has to have the same slope. The same slope. So the first thing you're going to want to do, well, before I go any further, make sure you write down these notes. Parallel lines have equal slopes. Perpendicular lines have slopes that are negative reciprocal of each other, of one another. All right, so go ahead and write that down. Pause it, do whatever you got to do. So the first thing you're going to want to do, if we want a line parallel to MN, we need to have the same slope. So how am I going to find the slope? Well, you should think to yourself, first of all, whatever I get should be negative because it's going down from the left to the right, which means that it is negative. Now, whenever I have a line on a piece of paper, not on a piece of paper, on a graph already, I like to just do rise over run, make my triangle, do it like this. Now, could you use the slope formula? Yeah, you could just take these points, plug them in to y2 minus y1 divided by x2 minus x1. So that would give you negative 5 minus 1 divided by 3 minus a negative 6, which is a negative 6 over positive 9, which is good because our slope should be negative. And if you did reduce that, you'd get negative 2 over 3. Now, if I were to count this, I'd say, all right, this is 1, 2, 3, 4, 5, 6. So our rise is actually negative 6 because it's going down. And then our run, 1, 2, 3, 4, 5, 6, 7, 8, 9. We get the same thing. So our slope is equal to negative 6 over 9 or negative 2/3. You can use either one. It would not matter. If you notice down here, we can eliminate two of them right now. Hopefully you recognize that we can eliminate these two. And now we have to figure out which one of these, one or two, is going to work. Well, we're going to now, remember we have a point P that we want this line to go through. So, you could have a lot of lines that are parallel to MN, but there's only one that's actually going to go through P. So we want the equation of the line that's going to go through point P. And if you remember, we had something called point slope form. And I want you to write this down. And that was y minus y1 equals m times x minus x1. All right, we have our slope, so we can plug that in, and we have our point, 6, 1. So I'm going to write that down over here, 6, 1. So we want to go through that point. So this is going to be my x1. This is my y1. So it's going to be y minus 1 equals negative 2/3 times x minus 6. So now I just have y minus 1 is equal to, now I have to distribute all this. That'd be negative 2/3 x, and then negative 2/3 times a negative 6. So negative 2/3 times a negative 6 over 1. I'll put over 1, so it's easier to multiply. And that is a positive 12 over 3, which is equal to 4. So we have negative 2/3 x plus 4. All right, and then to get in the same form as over here, you're just going to add 1, and you're going to get y is equal to negative 2/3 x plus 5. There you go. All right, so that is the end of that. I'm going to go over the problems 11 through 15 in the next video. If you have any questions on what you saw here, just feel free to ask me.